Hey everyone, Mr. Cam here, wanting to give you a Canada Day lesson on polyatomic ions. So do your best to try to follow along. Trying to make this video as short and sweet as possible. So the important thing is when we're dealing with bonding now, we've looked at bonding between two group A atoms, such as sodium in combination with chlorine, or like magnesium in combination with oxygen. And we've also looked at transition metals where you have, say, for example, copper combining with chlorine, where now you have to add Roman numerals. So what polyatomic ions are literally exactly as you see them. Poly, which means many, and atomic, which means that there's a lot of atoms stuck together. And ions, of course, means that there are charges that are found on them. So what does this look like? Well, luckily for us, you guys don't have to memorize the list. You guys will always be given the list. So just to recap, our polyatomic ion are groups of two or more atoms that are bonded together that have a charge on them. So you'll notice that the names of these ions are things like ammonium and hydroxide and phosphate and sulphate. You'll notice that none of them have the same ending as we're used to in the IDE. So that's where you can kind of pick them out very easily and saying, okay, if they're not starting with IDE, it means that we're probably dealing with a polyatomic ion, not a regular ending. So how do we go about using these? So before we move on, you'll notice that all the ones, or most of the ones that I presented to you here, are of the negative variety. Hydroxide is -1, phosphate is -3, and sulfate is -2. And all this means is that, like the hydroxide, for example, want to gain 1 electron, the phosphate want to gain 3 electrons, and the sulfate want to gain 2. But there are on the occasions that something like ammonium will have a +1 charge, which means that that ion wants to give away its electron. It's a wannabe. It acts like a metal, but you can see in that compound, there is no metal whatsoever, but it acts like one. So how do we go about figuring out like how these ions behave? So let's start with something fairly straightforward. We're going to do sodium hydroxide. So sodium, you guys already know, it's in group 1. It's an alkali metal. And this alkali metal will want to give 1 electron away. So its charge is Na+1. Hydroxide, if you look down your list on page 419, you're going to see that it has a charge of -1. You don't really have to know them until you get to SAGEP, and even then you'll probably have a list. So sodium wanting to give away 1 and hydroxide wanting to take 1 in means that, you know, if you wanted to kind of visualize it, you can say, okay, Na has 1 it wants to give away, and hydroxide wanting to take 1 in, imagine it has like 7. It acts like chlorine or fluorine. So it wants to gain 1 from the sodium and basically become a -1 charge, and the sodium will become a +1 charge, leading them to bond together in a 1-to-1 combination. So your final compound ends up being NaOH. Let's do another one together, okay? Calcium carbonate, for example. So calcium, as you guys already know, is an alkaline earth metal, which means that it's in the second column, Ca2 positive. It wants to lose 2. And if you look at carbonate, well, carbonate is CO3 with a -2 charge. And what this means is, if you want to visualize it again, calcium with 2 dots, and then CO3 wanting to gain 2, imagine it has kind of 6 dots around it. So it acts like a whole unit. So calcium will want to give away 1 and another 1, and CO3 will gladly take those 2, leading to you getting only 1 of each, and your final compound being CaCO3. Okay, so let me try another one with you guys, and I think that'll do it for this little lesson. It's really to just get you guys to start trying to figure things out on your own. Sodium, we already talked about being Na+, and sulfate, of course, is SO4 with a -2 charge. Okay, so when we draw them out, sodium will want to give 1 away, and SO4, because it wants to gain 2, is kind of like oxygen or sulfur, in that it wants to gain 2 more. So sodium can only give 1 away though, which means that we need another sodium to come along and give that extra electron to SO4. And After you figure that out, you're like, wait a minute, it's very simple in the way that it acts. I know that I need 2 sodiums, 2 NAs for every 1 SO4, which means that in the end, my final compound is Na2SO4. Okay, so I thought I would stop there, but let's do one more together. Calcium and hydroxide. This is probably the toughest of all the examples that we'll ever do for now, but you guys can totally handle this, I think. Calcium ion is Ca2+, as we already know before, alkaline earth metal, and hydroxide we already worked with earlier, being OH negative. So let's draw it out to make sure that we understand what's actually happening here. Ca with 2 valence electrons around it, and hydroxide, because it's wanting 1, will only try to take 1 off calcium. But here's the problem. Calcium, it has more than 1 it wants to give away. So what happens? Another OH has to come along with its quote unquote 7 electrons and try to bond to the calcium. And the calcium happily gives its other electron to hydroxide. Now, how do we show that there's a single calcium along with 2 of these OH polyatomic ions? Well, like in math, when we want to have multiple of something, we often put that thing in brackets, which is why with the 1 calcium and the 2 OHs, we end up with a formula where we have Ca open bracket OH close bracket 2. So I'm hoping you guys find this helpful, because you guys are learning it for the first time on your own, and I'm hoping that it's been helpful. Okay, so have a good one. Good luck with it, and I'll see you all soon.